Hi guys, Henrik Scholder here with Mechanix Menace. I am sitting here with a bunch of 3D printed parts, and you might wonder, what will all this be for? Well, if you read the title of the video, you might have a hunch. It's actually not for my car, Mechanix Menace, but it's for a friend's road racing Corvette C5. He ran it with an LS engine with fuel injection last season, but due to class rules he is swapping to a carbureted engine. They have some rules which makes it more competitive. So one problem he ran into is with the tall intake manifold and the carburetor, the carb actually sticks up through the hood, and he initially planned on using a normal 14-inch air cleaner and then a hood scoop. But when he kind of looked it through, he found out that the scoop would be really tall and it would obstruct the vision. So instead we came up with a solution where he will use the standard air filter box, and I am helping him design and 3D print molds for an air plenum, carburetor plenum instead. And that will not stick through the hood as much. And before I show you how all these will be put together, I can give you kind of a little background on when I designed this, how I decided on some shapes and forms and so on. With my Datsun 240Z, when I ran it with the first V8 Chevy small block 350, I basically had the same issue. The carb was really close to the hood, and in order to not have to use a hood scoop, I made an air cleaner assembly that kind of went very low beside the carburetor. And at that time I worked at the Swedish truck maker Scania. I developed intake and exhaust ports for the engines, among other stuff. And I actually did a flow test where I tried out how close can the air cleaner lid sit above the carburetor without getting any air restriction. And I found out that you can really get close without actually influencing airflow. So what I did is I took a normal Moroso 14-inch air cleaner, cut out a lot of stuff, and then I made this base here, and as you can see it really kind of goes down above the carb, and you have these two little bumps here to accommodate the float bowl set screws, another bulge here for the throttle linkage, and then actually it's hard to see, but the air cleaner lid was also shaped to mimic the shape of the hood. So this sat something like this. I used a 4-inch filter element, and I think the spacing between the top of the carb and the lid here was like a little more than an inch. And then I had like 10 millimeters or 3/8 of an inch space to the hood, and everything worked out really nicely. So with that knowledge we kind of decided to do something similar with his car, having the air plenum as low as possible but still not restrict airflow into the engine. So let me put this together to see how it all looks. So this is what it will look like all put together. These 6 pieces will be glued onto a base plate, and this is actually the mold then for the bottom half of this carburetor plenum. He will glue this together himself, and then he will make a carbon fiber bottom part. I have not yet 3D printed the top part, but that will look something like this as well. And we will have a edge here which will be glued together, so we will have a little overlap between the two halves so he can epoxy them together. And yeah, this is actually the by far biggest 3D print project I have done so far. It's gonna be around 300 hours print time, and it'll use like 3 kilos, so more than 6 pounds of filament. It has worked out pretty well so far. I've had some issues, so some of the parts I have had to reprint, but yeah, I think in the end it'll all work out nicely. In deedly doodly. And yeah, you can see here, these are the bumps for those carburetor float bowl set screws. What else? Yeah, I've tried to keep the shape as aerodynamic as possible, and with my experience from the work I did there at Scania, I think I know enough to make this work out. So here, of course, the standard airbox will be somewhere here, and then it'll connect to this round part here, and then all the turns and things are as gentle as possible, and you have like a diffuser here, so you're not getting a lot of flow losses, which you would get if you just had this round tube coming into a big plenum here with a sharp edge. But here you're actually slowing the air down without any losses. And also the shapes here are really rounded, so the air can flow nicely up and into the carburetor. And we will have a look at the CAD model to see the entire design. The top half is shaped a bit strangely due to the visibility issues, but at the same time try to not restrict airflow, so it'll have a kind of a different shape. Okay, that's it so far. Thanks. So let's have a little closer look what it looks like. Okay, so let's have a look at how this project started. Here we can see a picture of the car with the carburetor, and as you can see, it's quite high above the hood. So my buddy realized that with a normal air cleaner and a scoop, this would be quite tall and it would hinder visibility too much for his liking. So what I asked him to do was to take some measurements from the carb to different parts that would decide the shape of the carburetor plenum. So here are some of those measurements. It's mostly the intake manifold and the valve covers and the ignition coils that are kind of limiting the shape of the plenum, and of course the hood itself as well. So after that I started modeling. This was an iterative process. We went back and forth a lot of times, and when I had come up with some new models, I sent him some cross sections which he cut out in cardboard and then test fitted onto the car. So this is one of those cross sections, and as you can see here, he's cut a bigger hole in the hood, so even with this type of intake or carburetor plenum, it'll still stick out or stick up quite far from the hood. But yeah, that's how it is with a tall intake manifold. Another view here. and from the side, and here you can see the stock air filter box, and there will be a connection between this one and then the front end of the carburetor plenum. I should go back. I also asked him to modify the carburetor linkage. Stock, the linkage or gas wire attaches here at the top, but that would put too much protrusion, or it would obstruct the shape of the plenum too much. So he made a new version here with this wheel here, and the gas wire goes here, and then you have a linkage to the bottom half here of the arm. So this means that I can make the intake plenum fully symmetrical, and there's no need to make any kind of bump in it to accommodate the throttle linkage, which is nice. And here you can also see these bumps over the float bowl set screws here, which are necessary. They're fairly narrow, so they won't hinder airflow very much. Yep. And a view from underneath the hood. So the plenum kind of dives down here in the front to connect to this tube coming up from the stock air filter box. Okay, let's take a look at the CAD model. The first thing I did was I 3D scanned his carburetor with the result looking like this. As you can see, I haven't scanned the entire carburetor, just kind of the top part, and it looks not so super duper good, but I have all the dimensions I need to create the model, so this is good enough. And from this model, or that scan, after many hours of modeling, I ended up with this shape here. So if we take a look at a cutout, you can see the carb here, and you see there is like a ridge here. The reason for this is, of course, to accommodate the breather tubes for the float bowls. I could make the top of the cover as tall as all the way up here, but then it would restrict vision more. As it is not right now, this is basically just a little fin at the top, so this won't restrict vision, but you still have these tall tubes preventing any fuel spillage during cornering, acceleration and braking. And you don't need a lot of space here because there's no airflow going into them. They just need to feel the pressure in the plenum. And also the reason for this flat portion here is he will drill a hole here and then use a normal air cleaner stud to attach the whole plenum to the carburetor. And yeah, a lot of work was put into, like I said before, making all of the transitions as nice and smooth as possible, and try to keep area changes gradual, and have everything as aerodynamic and as little flow restrictive as possible. Yeah, let's have a little look from the front. So if we go from the very front, air comes in here, and whoops, let's see, and then you see the area increases gradually, which means that you will not have any losses when it goes into the actual plenum, and everything is rounded and nice. And the reason for the shape here is that we decided upon, or actually he said He was good with 30mm height here from the top of the carb, and from my measurements when I worked at Scania, as I said before, I knew that this distance here would be enough to not create any flow restrictions. And then from here I just made these gradual increases in flow area, so you have like a nice funneling effect into the carb like this. And the tall part of the plenum, he wanted to keep that as narrow as possible for visibility reasons, but I think the hood is I don't know, somewhere like here, and then below that it could extend outwards to increase the area besides the carburetor. And if we have a little look from the bottom, looks like this. Whoops. And here you can see the seam between the two parts that will be glued together with an overlap seam here. And the actual molds for this look like this. This is what you saw earlier. So these are all the 6 parts glued together. And to reduce the amount of filament and printing time, instead of making these parts go all the way down here, I instead designed a base like this. So this will be glued or screwed together with particle board, so it'll save a lot of hours printing and a lot of filament as well. And yeah, he will glue this together and start laying up the carbon fiber bottom soon. Today I sent him all these pieces, and the top part will look like this. So here you can see the seam that I talked about with the overlap, so he can glue the two parts together. And now I just have to print all of these parts, also 6 parts. These are a little less tall than the bottom ones, so it will be a little bit quicker, but according to my slicer, I think the entire project, as I said before, will take something like 300 hours. Yeah, I'll be glad when it's over, but it'll be super interesting to see how the end result comes out. And of course I will include that as well in this video, which will be, I don't know when, but sometime in the future. For you, doesn't matter. It'll all be in the same video. But that's it for now. Thanks for watching this far. So this is how the top part of the mold came out with all the 6 pieces from a couple of different angles. Here you see that ridge there for the float bowl vents. And I did post the start of this project on a Facebook page, and it was quite a bit of interest. And there was a guy who offered to do some CFD. So after some time, he sent me a couple of plots. This is a velocity plot. And here you have another one where you can also see the flow lines. And he also sent a couple of animations. This shows the flow trajectories and the pressures in the different parts of the entire airbox. And this is also flow trajectories, but instead velocity. There are some interesting recirculations going on. I asked him to explain a little bit more and maybe come up with some suggestions for improvements, but unfortunately he never got back to me. And these are pictures I received from my buddy, This is the base he made for the bottom part of the mold. And here you can see the 3D printed pieces in place. And yeah, he made kind of a, what do you call it, a big vise to glue the parts together and then glue them onto the base there. Here he has sanded and primed the bottom part of the mold and started to lay up the carbon. Yeah, here he has taken the bottom part of the plenum out of the mold. I did make the mold with draft angles, but yeah, he had some issues getting the part out of the mold, so as you can see he had to break the mold, unfortunately. And there it is, trimmed with all the edges. Looks fairly nice. And on the engine in the car, here he is primering the top part of the mold. And here the entire plenum is temporarily taped together. And again put on the car. And here you can see the opening he had to make in the hood to make space for it. So it's got to be a really tall manifold since it still sticks up quite far from the hood, even though the whole thing is quite low. And here he has glued the two parts together. And there you can see the throttle mechanism below the plenum. Here it is finished. He did put the car on a chassis dyno, and the horsepower and torque numbers came out roughly as expected. He didn't want me to divulge any figures because he doesn't want his competitors to know. But everything looked fine, and I think he ran one race, but then suddenly he got some issues with the air fuel ratio. So after some thinking back and forth, he came up with the theory that the float bowl vents maybe still were too close to the top of the plenum. So he came up with a little bulge that he put on top of the plenum. He cut out the top part with that ridge for the float bowl vents and instead put this on the plenum to raise the distance there. And not sure exactly if that was the case, but after that change, everything worked out better. So yeah, of course visibility was reduced a bit more, but still, yeah, he's pretty happy with the result. And I think, yeah, this video has taken quite some time for me to make. So the project started in February last year, 2025, and I think this picture was in August. So thank you for watching, and again, if you have any questions or comments, don't be afraid to ask them. I think the next video will again be something that covers my car, Mechanix Menace. Probably again a little bit about the chassis welding, which is what I'm doing right now. Again, thank you, and until next time, bye.